cosine, and many others. We were able to see how they relate with each other, and this was majorly through our identity, the Pythagoras identity, the sine squared theta plus cos squared theta to give us the tan squared theta. Okay, so today we are actually now going to get into more of the questions, more of answering the questions, more of solving trigonometric equations. Yes. So I want us to start firstly with the I would love to call them special angles. Since our trig functions are dealing with angles, there are certain angles we ought to know even before we press the calculator. We have an angle of 30 degrees. We have an angle of 45 degrees. And then we also have the angle 60 degrees. Right now I will state what is special about them, and then we shall prove that using, of course, mathematical knowledge. The sine of angle 30 is a half. The cosine of the angle 60 is also a half. And then the tangent or the tan of angle 45 is a 1. That we should know without touching a calculator, that the sine of 30 is a half, the cosine of 60 is a half, and the tan of 45 is a half. Of course, it is not, of course, this is science. We must be able to prove that. I want to draw for us a triangle where all sides are equal. We call this an equilateral triangle. Yes, the shape has come out. It has come out well, assuming. Now, when these sides are the same, when these sides are equal, it also causes these angles to be equal. Now, we know that the angle sum of a triangle, the total angle sum of a triangle is 180. So, since these angles are 3, this is one angle, another angle, another angle. They are 3, they are equal, yet the total angle sum is 180. So it automatically means that each angle is 60 degrees. This angle is 60. It could be any length, so I can just make it an unknown, whether it's 1, however, as long as each one is 1. Okay, all sides are equal, all angles are equal. That is an equilateral triangle. Now, in this equilateral triangle, all the angles must be 60. There is no other angle that can be in an equilateral triangle. It's always 60. The length can change as long as it is equal length, 1.2, 1.2, 1.2 meters, 2 meters, 2 meters, 2 meters, but always the angle is going to give us 60. Okay, I hope that is well noted. Now what I am doing is that I'm going to bisect this triangle. Of course, bisecting means I'm going to cut it. I am going to split this into 2 equal parts. This is where I'm bisecting from. I'm bisecting along this axis. Okay. I get a right angle triangle. When I just take one piece, this length was x. This is this angle, which is 60 degrees. Okay. And then this angle, this upper angle here, the double of the whole angle was 60, but now I have divided it into 2 since I cut it into 2 equal parts. So automatically, of course, that would be a 30. Yeah? Hope that is clearly visible. So when I have a 90, a 60, and a 30, I get my right angled what? Triangle. Now this length is x. This downer length, the whole downer length was also x. But since I have divided into 2, it means this new length here is actually a half of x. I have this other unknown length. Let me just call it h for height. Since I have one unknown by Pythagoras theory, I can get it. I want to have all the length in terms of x. This is in terms of x. This is in terms of x. Only the h is unknown, so I should also get it in terms of x. But by Pythagoras theory, which we did last time, we said that the sum of the smaller sides, this side h and this side half x, the sum of their squares gives us the sum of the square of the hypotenuse. So if I have a half of x and I square that plus h squared gives me the hypotenuse, which is the longest side, also squared. That is my Pythagoras theorem. I think we are very familiar. We had a lesson about it. In case you were not there, you can, of course, first watch that video, or you can go through that video after this one so that you have a perfect knowledge. Yes. Now, since I want to get the value of h in terms of x, I will make h the subject. I'll have h squared being equal to x squared. So I'm going to carry this and I take it to this side. Since we are crossing the equal sign, it's going to become negative. Okay, at the same time, I am squaring. When I square a half, I get a quarter. And then when I square the x, I get x squared. Okay. So that's the value of my h squared. My h squared is equal to x squared minus a quarter x squared. So what we do here is I want to get the value of h, not h squared. But let me first subtract this. X squared minus a quarter x squared can be subtracted. This x squared has a silent 1 behind it. There's like a silent 1 here. So it's as if I am actually subtracting 1 minus a quarter. 1 minus a quarter. Yes, 1 minus a quarter, you get 3/4. So I actually have 3/4x squared. That is the value of h squared. And of course, that was going to imply that h, to get the value of h, I simply take the square root. So my h is the square root of 3/4x squared. Hope we are following. H is the square root of that. If I make the root to apply, I will have h. I don't have a perfect root for 3. I don't have a perfect root for 3, so 3 will remain in the root. I'm going to call this root 3. I have a perfect root for the 4, which is down, and that is a 2. So I will have root 3/2. Then I have a perfect root for x squared. This squared and the square root would just cancel. So I have 3/2x. Okay, very good. Now I'm going to redraw my triangle, and this time I'm going to put those unknowns. I'm going to put the value of h in terms of x. So if you were following, you noticed we drew it an equilateral triangle where all sides were 30. I mean, all angles were 30, and then the sides were x. But then we divided into 2, making this angle to divide from 60 to 30, and this side to divide to a half of x, and this was an unknown. This long side here was this vertical side was an unknown, which we have actually calculated here, and we get it as root 3/2 of x. So I have root 3 divided by the 2, which then multiply by the x. So that is our triangle, which has now everything. I'm going to use this triangle to prove 2 ratios. I'm going to use it to prove the sine of 30 and the cos of 60. Remember, I told you the special angles were 3 special angles that we just want to prove or to derive, that the sine of 30 is a half. I want to see that the sine of 30 is a half, the cosine of 60 is a half, and the tangent of 45 is 1. In the equilateral triangle that we've just had, we can prove 2 of them. We can prove this 30 and then this 60, because they are in that triangle. We don't have any angle 45 within. That one we shall do independently. Okay, so this is where we were. So remember SOHCAHTOA. SOHCAHTOA, we said so is telling us that the sine is the opposite over hypotenuse. Ka is telling us that the cosine of any angle, you get the adjacent over the hypotenuse. And then the TOA, which tells us that the tangent is the opposite over the hypotenuse. Okay. The previous or the first lesson, we talked about which side is hypotenuse, and that's the easiest to remember. Hypotenuse is the longest side, of which this is the longest side. That's our hypotenuse. Which side is adjacent? Adjacent is not any specific side in a triangle. It depends which angle are we dealing with. But the adjacent, we said it makes, it's the side which makes the angle together with the hypotenuse. If I am dealing with angle of 60, this half x side becomes the adjacent. Okay, then the opposite side is the side where the angle, in which the angle is facing. This angle 60 is facing this side of root 3 over 2x. That becomes the opposite. Very good. Very good. If you understand that, then you are very well. So dealing with the 30, we said we want to prove that the sine of 30 is a half. So sine of angle 30, this angle 30 here, is going to be equal to the opposite, which is a half x. This is the opposite. The angle is facing there. This is a half x over the hypotenuse, which is just x. Half x over x, x and x, they go wherever they go. So you remain with a half. And hence we have proven. Simple things. Simple. Yet very important. You are going to see how important that is in the as we proceed. The other one that we wanted to prove was that the cosine of angle 60 is also a half. The cosine of 60 is basically adjacent. Remember our car. Adjacent over hypotenuse. The adjacent angle, the adjacent side to this side of 60 is this half x side. So I have a half of x as my adjacent over the hypotenuse, which is our longest side, and that is also x. And also the x is going to cancel out and will remain with a half. So whenever you are in the calculation and you get cos of 60, get sine of 30, you do not have to press the calculator. Okay, you can. It's calculator is used, but you must get a half. It is possible to press the calculator and you don't get a half. And that would imply you need to check the setting of your calculator. Make sure it is in degrees. Whenever we are dealing with these angles, this big angle 30, 60, 45, it should be in degrees. Yes. If it is in radians, you'll get different figures. So be privy about that. Okay, that is those two angles proven. To prove the one for the for 45, I am going to draw for us a right angle triangle where two sides are equal. We have proven two of them. Imagine a right angle triangle where two sides are equal. Now, in a right angle triangle, we know that this side, this angle here is 90. So I'm saying these two sides are equal. And so I can assign them the same length, any length, which is the same. If that is x, this is also x. Okay. Now, if the two sides are equal, even the two angles are going to be equal. Our total angle sum is 180. We already have a 90 here that is giving us a right angle. Meaning I have 90 remaining to give us the total angle sum, which is being divided by these two angles. But we have said that if the sides are equal, then the angles are also equal. Yes. So if the angles are equal, they are automatically going to be 45 each. Each angle is a 45. Very well. By Pythagoras theorem, I can know the length of the hypotenuse. We said the hypotenuse squared is equal to the square of the shorter sides. So since the hypotenuse is not known, I'm going to assign it an unknown. Then we use Pythagoras theorem to find out the value of this unknown. So the shorter side, I'm starting with this one, this side squared plus this other side, which is like the base squared also, gives us the longest side squared, that is the hypotenuse. X squared plus x squared, there's a silent one behind each of them. So it's like I'm saying get one x squared, add on another one x squared. Obviously, you get 2x squared. Obviously. There's a silent one behind that you should need to mind of. So this is 2x squared being equal to the hypotenuse squared. And that, of course, implies that if I take square root on each side, I'm going to get the hypotenuse as the root of 2x squared. When I apply that root on each individual term, 2 does not have a perfect square root, so it stays. I don't want to go into decimal places. So I just remain with the root 2, and then x squared has a perfect root, which is simply x. Okay. So I'm going to replace that here, but I'm going to redraw everything. Yes. So we have our right angle triangle with two sides equal. This length was x. This length is also x. We found the length of the hypotenuse as root 2 of x. The x is out of the root because it was an x squared. This is angle 90. These two angles are 45. 45. Yes, such that the total angle sum comes to 180. Please, if you ever draw a triangle and your angle sum is greater than 180, either run or you remove the triangle, you draw another one. It's wrong. There's no triangle which can have total angle sum that is not 180. It should be 180 exactly, not less, not more. Okay. Now I want to use this to get the tan of 45. The tan of 45. I can use any angle here, but I'm going to use this one. It's more direct. This is my hypotenuse. If I am using this angle, this is going to become my adjacent. And this angle is facing on this side, this vertical is going to become the opposite. From SOHCAHTOA, tangent of any angle is the opposite over the adjacent. So tan of 45 is the opposite. This is the opposite, which is actually x over the adjacent, which is also x. And x cancel out. Hey, so when some children cancel out x and x, they remain with 0. No, it's not 0. It's like saying 5 divided by 5. You get 1 out of 1. So x divided by x, you get 1 out of 1, which is simply 1. And that is a confirmation that the tangent of 45 is 1. Okay, so proven. Even these were proven. Proven and proven. Okay, so one more thing we are going to do first is to, what we are going to do next is to see how we can represent these angles in a quadrat. How we can represent these angles in a quadrat. Just a reminder, we had this as our quadrat. We said that the total degrees that we can have in a complete cycle is 360, and we divided this into quadrats, into 4 equal parts, implying each is 90. This is 0, this is 90, this gives us 180, and then this gives us 270. And back here at 0, we shall have 360 degrees. Okay? So we need to actually know how we can represent this. Any angle, any size of the angle, it can actually be bigger than 360. We need to know how we can represent it on quadrats. We need to know how we can represent that on quadrats. So I'll give a simple subheading, representing angles in our quadrats. In quadrats, we have 4 quadrats. These are the angles we are going to represent. We are going to represent the sine of 30. We're going to represent the sine of 150. We're going to represent the cos of 210. We're also going to represent the cos of 540. Now remember, this quadrat begins from 0 degrees to begins from 0 degrees to 360 degrees, but we can use it to represent even angles that are bigger. Okay. One other thing to put in mind is that we said all students take coffee. Here, we said all the trigonometric functions give us positive values. Students, we said only the sine gives us positive values. Take, only the tangent gives us positive values. And then coffee, only the cosine gives us positive values in that range. From 0 to 90, all angles of any trig function, whether be sine, whether be cos, whether be tan, it's positive. Okay, that we did in the previous section. No more. No need to go deeper into that. So starting with the first one, which is the sine of 30. I'm going to represent the sine of 30 on that quadrat. So I'm going to draw it like this. And I measure 30 degrees. Assuming my 30 degrees are here, this is 30. Whenever I'm measuring anti-clockwise, that angle is positive. So there I have represented sine of 30. I have represented the angle 30. Yes, the angle 30. Yes. And if I want to represent the angle 150, I can get its value. Sine of 30, I know it is what? A half. And it is positive. Positive because it is in the first quadrant where all are positive. The next is the sine of 150. The sine of 150 I measure the angle always from this axis, the positive x-axis, and I measure, if it's a positive angle, I measure it anti-clockwise. Anti-clockwise, I am going this direction. If the angle is negative, assuming I was measuring sine of negative 150, I would take this clockwise direction. Okay, let's take what the question has asked. So the sine of 150, I would measure 150 degrees. 150 degrees is beyond the first quadrant, because from here up to here is 90. Okay, so I need more 60. Yes, more 60 to make it 150. So I would continue measuring until I measure what? 150 degrees. So this is 150 degrees. But I want to get the value of sine 150 even without using a calculator. Now, since we know that this side was 90, automatically I've added this side as like a 60, and here I have remained with a 30. Yes, with a 30. Here all are positive, sine is positive. Now my angle of 150 is falling in the quadrant where sine is positive, and I want the value of the sine 150. So my figure, my answer is going to be a positive. So my sine of 150 is a positive. But my sine of 150, when I am counting from the positive x-axis, is the same as sine of 30 when I am moving from the negative x-axis. So the sine of 150 is the same as the sine of 30. Oh, yes. The goal is reaching this line here. That's the goal. How do we reach here? I can reach there by taking this route where I have 1 what? 50. Or the other shorter route is me measuring from the negative x-axis, and I measure 30 degrees. So sine of 150 is the same as the sine of 30, and my value of sine 30 is a half, which is positive. Let me take one more example, which is going to help us understand clearly. I'm going to also measure the sine of 210. We had said we take the cosine, but let's take the sine of 210. This gives us the picture. It's going to give us the whole picture very well. 210 is beyond. This is 0, of course, 90, 180. It's beyond even 180. It's beyond 180 by 30 degrees. If you take 210 minus 180, we get 30. So we are dealing with another 30. Yes, meaning I'm going to move up to 180, then I add on 30. This is my 210 degrees. All students take coffee. For me to measure 210 from the positive x-axis is actually similar to me measuring 30 degrees in the third quadrant. It's equal to me measuring 30 degrees in the third quadrant. However, in the third quadrant, sine is not positive, it's negative. Only tan is positive. So I can rightly say that the sine of 210 degrees is equal to the sine of 30, but this time it's a negative. Sine of 30, but it's a negative. Are we following up to that point? Very good. Yes. So the sine of 30 in the first quadrant is the same value as the sine of 150 in the same quadrant, and is similar to the sine of 210 in the third quadrant. The only difference that this in the third quadrant, sine is a negative, only tan is positive, and that causes this small change. Okay, so one more on this, and we of course get into others. One more of this, and we get into others. A chance for you to understand if you have been left behind. I want to measure the cosine of 540. I want to get the value. I want to know the value of cos 540. Okay, cos of 540. I have my quadrant that runs from 0 to 360 when I make a complete cycle. Now, 540 is bigger than 360. And it's bigger by which magnitude? I can do that by subtracting 360. When I get 540, I hope you're taking your calculator. Minus 360. I hope we are all getting 180. Yes, 180. So I can represent that on this quadrant, though it seems a smaller one. So to represent that angle 450, I'm going to measure one complete cycle. And then I add on the remaining angle, which is yes, which is 180. So I can rightly say that the cos of 540 is the same as the cos of 180. The cos of 540 is the same as the cos of 180. You can prove that on your calculator. Okay. Of which the cos of 180 is negative 1. The other angle would be the cos of, let's do 420. The cos of 420, you get your 420 and subtract 360. Why are we subtracting? Remember, our we say that our quadrant is having our complete cycle with angles, with degree 360. So when we get to anything beyond 360, we must just subtract 360 from it to know, okay, what is the remainder? In simple terms, you're saying, let me actually show you from here. If I draw a quadrant, I'll represent this as 0, as 90, as 180, and as 270. So where is the 360 we are talking about? To make 360, you come back at 0. So whenever someone moves 360 degrees, they have come back from at the exact point they started from. It's like 0 work done. Probably basically that, yes. The displacement is 0. I think this is right even in actual sense. If you're standing and you turn through 360 degrees, you will face exactly where you were facing. So in angles, angle 0 and angle 360, they are the same. 0 degrees is the same as 360 degrees, which is the same as 720 degrees, and all multiples of 360. So whenever you are given an angle which is greater than 360, we have to reduce it back into less than 360 so that it can be represented on this diagram by making simply turns, by subtracting the 360. Okay. So the cos of 420, I will first say, okay, 420, when I remove 360, what do I have? 420 minus 360, I get, I think I get 60. Yes. So the cosine of 420 is actually the same as the cosine of 60, of which the value of the cosine of 60 is known as a half. So cos 420 is also a half. Yes, you would prove that on a calculator. Okay, I think that is enough background for us to start solving trigonometric equations. We are starting the solving. Unless a question comes up, I'll just have to continue. So please, you make sure I don't leave you behind. Okay. Okay. Good. So tell your neighbor business now. Business. This is now what they are going to say. Solving trig equations. You are going to need the knowledge of quadratic equations here, plus the background we just covered. And solving quadratic equations, you studied that in O-level. Even if you've not yet covered it, yet again in A-level, of course it's part of the syllabus, you can do. So I'm writing the first question here. And our first question is, solve the following equations. Solve the following equations. And we are given a range of degrees, 4, 0 degrees, less than or equal to theta. Theta is going to be our angle. And this is less than or equal to 360. So we are basically being told by this range that our answers should be between 0 and 360. We should not go beyond that. That's the meaning of that range. Simple meaning of that range. Okay. The first equation we are to solve, we have been told that the sine of our angle theta is negative a half. The sine of our angle theta is negative a half, and so we are needed to find the values of theta. Okay. Now to find theta in such an equation, if we have sine, we always introduce what we call the sine inverse. Sine, you introduce the sine inverse. If it's tan, you introduce the tan inverse. Why do we introduce that? You're going to see. I'm going to introduce the sine inverse on both sides. Sine inverse of sine theta. And then I take also the sine inverse. I'm going to take the sine inverse of a half. I'm ignoring that negative, but I'm going to use it in the quadrat. Now, when sine and sine inverse meet each other, these ones always cancel out. When sine meets sine inverse, they say we go. So they leave the angle. Theta is the sine inverse of a half. You can press that on a calculator and you get the value. Theta is the sine inverse of a half. To press sine inverse on a calculator, you'll press shift sign. You press your shift sign and then you open brackets. You can write 0.5 or you write 1/2 and you close brackets. I prefer you use brackets when you're entering fractions, just to avoid errors. Okay. Theta is the sine inverse of 1/2. And when we press that on the calculator, I hope some people have gotten it, and that is 30 degrees. I am getting 30 degrees. Unless someone has gotten a different one, but that is what we all expect to have. If you have a different one, check your calculator, change it to degrees, set it into degrees. I know someone could help you that to do that. So theta is 30 degrees. This is not the answer. Our answers, we've been told that they should range from 0 to 360 degrees. Now, I am going to represent this 30 degrees on this on these quadrats. All students take coffee. Now, before I did the sine inverse, the value of my sine theta was -1/2, meaning I am going to only use quadrats where sine is negative. Where sine is negative, those are the only places where this 30 satisfies. Now, when you look at the first quadrant, all of them are positive. That means I cannot use that. The second quadrant, sine is positive. I leave it. Why? My sine theta was -1/2. It was negative. So I get here where tan is negative, I mean positive, and that means the sign is going to be negative. I measure 30 degrees from the x-axis. Always we measure from the x-axis. We never measure from the y-axis. In any quadrant, when you're measuring the angle, measure from the x-axis that is close to that quadrant. We have two x-axis here. X-axis, we have the positive x-axis and the negative x-axis. Okay, and then I can also represent the other 30 degrees also this way. Remember, I've been told that my answers should range from 0 to 360. So both these angles are in the range. Both these angles are in the range. 0 to 360 completes my all the quadrats. So after representing the 30s in quadrats where the sign is negative, I now measure to get my final answer. I always measure the final answer from the positive x-axis. So I measure this angle here. And I also measure this angle. Can someone help me find out how many degrees these are? Yes, anyone who can help me with that, just to measure those angles. Okay, we do it together for this one. This is of course 0. From here 0. This is 90. This is 180. and one of them is ending here. So I just get 180 plus disc 30. 180 plus 30. So theta becomes 180 plus 30, which is 210. Theta is 210 degrees. I also have to measure this the last one. 0, this one is almost taking a complete cycle. 0, 90, 180, 270. This is 270. Now 270, I'm moving again up to this point. I'm only leaving 30. I can actually say it is just the complete cycle minus 30. I think that would be easiest. Complete cycle, which is 360, minus deca 30, which was remaining, I would get 330 degrees. Those are my two values of theta. Yes, I am going to, as we solve angles, some angles actually are going to give us some values of theta are going to be, it could be 1, it could be 2, it could be 4, it could be 6, it could be 10. I could have one equation that has 10 angles that satisfy it. So you must learn that quadrant very well. If you learn it very well, you are a good trigonometric student and a threatening good mathematician. Yes. Okay. So that was the first example. A short recap. Our equation was very simple. Sine theta is equal to negative a half. To get the value of theta, remember we were asked to solve the equation for 0 theta 360. So it means we are finding the values of theta. So I want to remove the trig functions from theta. So I have sine theta is negative a half. What I do, I introduce sine inverse on both sides. Sine and sine inverse cancel out. And then the other side, I take the sine inverse. It does not matter the value that is there, whether it's positive or negative, always take the sine inverse of the positive, of the positive form. The sign that is there will help us to find out which quadrant it falls in. Now, since that was a negative, after taking the sine inverse, we get 30. We got 30. That's not our answer. It's not the answer. Now, ask ourselves, okay, 30, but in which quadrants? In the quadrants where sine is negative. You come and represent it in here, in the third quadrant where sine is negative, and the fourth quadrant where sine is negative. You measure the angles, the 30, from the x-axis that is close to that quadrant. Here, I measured the 30 from this negative x-axis. And then in this fourth quadrant, I measured it from the positive x-axis. I measured the 30. Okay? Now, after that, the final answer should be measured from the positive x-axis anti-clockwise. Positive x-axis anti-clockwise to the line you have drawn. My 30 was here, so I measure from the positive x-axis to that. And then my other line is here, so I measure from the positive x-axis all along up to here. And those angles are the final answers. They are the final answers. You can prove in your calculator. You go and press sine of 210, you must get negative a half. Press sine of 330, you must also get negative a half. So this topic you do as you mark yourself. Like you finish and you know that, oh, I have passed. You don't wait to collect and they mark you. No, you can know. So it is good to know that you've passed, but if it has not come out, still you can also know that it has not come out. So make sure it comes out. The second that we are going to do is sec. We want to find the value of sec theta. I mean the value of theta when sec theta is 2. Sec theta is 2. Now there are basically 3 trig functions that we love to work in, more so taking their inverses. That is sine, cos, tan. That means I would have to remove that sec. I mean to express the sec into any of those 3 forms. And the easiest is going to be, I think, the cos. Cos. Yes, we said sec theta is equal to 1 out of cos theta. So I would be very right to just, in my first step here, to first convert that to cos theta. I say 1 out of cos theta is equal to 2. Okay. Then 2 is the same as 2 over 1. I am taking the, I want to cross multiply. I want to make cos theta. I want it not to be a denominator. I want it to be a whole number. So when I'm cross multiply, I get 2 times cos theta is equal to 1, and that implies when I divide by 2 on both sides, that cos of theta is 1 out of 2. Okay, cos of theta is 1 out of 2. Remember how we began? We were given sec theta. We cannot work with sec theta. In our quadrants, we don't know sec theta. We know sine, cos, tan. All students take chemistry. There is no sec there. So sec is 1 over cos. Yes, and then make cos the subject. So cos theta is a half. At this point, we are going to introduce cos inverse on both sides. In the first example we introduced sine inverse. Why? Because we had sine. We had sine theta is negative what? A half. And so we introduced sine inverse on both sides. Similarly here, since we have cos, to eliminate that cos, I'm going to introduce cos inverse on both sides. So I have cos inverse being introduced on the side of cos theta. And here also I have cos inverse of a half. Here I'm taking cos inverse of a half because it is already positive. If it's negative, ignore the negative. Ignore. Okay, you've understood. Now, cos of cos inverse, they marry when they meet. I remain with theta. Theta is the cos inverse of a half. When you take the cos inverse of a half in your calculator, like I have done in mine, I am getting 60. 60 degrees. Many students think that is the answer. No. Answers are usually plural. It could be part of the answer, or it could not even, may even not be part. Like in the first example we saw, we got sine inverse, and it gave us a 30, but our final answer didn't have a 30. So this is just one that's guiding us. I now draw my quadrat. All students take chemistry. Okay, cos of theta was a half. A half is positive. So I'm going to represent this 60 in quadrats where cos is positive. Where cos is positive, automatically the first quadrat qualifies. I measure 60 degrees. Even the last quadrat also qualifies. I also measure 60 degrees from the x-axis. The rest don't qualify. Now thereafter, I make sure I measure all of them anti-clockwise from the x-axis, the positive x-axis. I make sure I measure them anti-clockwise. The first one, the 60, is already 60. It stays. But the second one, I had measured the 60, but I had measured anti-clockwise. So I'm going to measure now the clockwise. The clockwise. The clockwise, like clock and wise. So my values of theta after being clock and wise, the anti-clockwise. Oh, is the anti-clockwise. My one value of theta is 60 degrees. The other value of theta, I want to know the value of this. There are several ways you can know. I know that from here up to here is 270. This is 270. And the remaining quadrant is 90. So if I'm remaining with this 60 on this side, that means this portion is 30. That is 270 plus 30, that is 300. Or I get 360 minus this 60. Because the whole complete cycle is 360. But I've only left out 60. Meaning my two answers are 60 degrees and 300 degrees. 60 degrees and 300 degrees. Are we at the same page? So we may continue. Okay. All right. All right. So those are the two values, our two answers. And that is how we solve these trigonometric equations. Please, you don't hesitate to ask a question. In case you have been left. I think most of you have been right, not left. Sit on the right column in class. That's our full working. So this was quite a high order. It required us to first convert from sec to cos, make cos the subject, take the cos inverse, and then represent on the quadrats to get the final values. We advance, we continue. We continue. The third question that I want us to do, the third equation is when the sine, we are given the sine squared theta as a half. The sine squared theta as a half. The first step, of course, the best step, the first best step to do here is simply to take the square root. We don't want to work in the squares. We just want to work in numbers that are not squared. So when I take the square root on both sides, this is what I'll have. I'll have this, the square root of sine squared theta is equal to the square root of a half. And that would imply that the sine of the angle theta, the sine of the angle theta is equal to, now when you take the sine, you're going to have two answers. Whenever you take the root, square root, sorry, you're going to have two answers. One is positive and the other one is negative. This is root. The square root of 1 is 1. The square root of 2 is not a perfect answer, so I'll leave it in square root sign. 1 over root 2. Plus or minus, those are two values. I'm meaning that the sine of theta is 1 over root 2, and the sine of theta is also negative 1 out of root 2. Pay some good attention here. Maybe someone is asking, but why positive or negative? The square root of a 4, is 2 or negative 2. You can prove that. When you square each one of them, you get 4. When you square 2, you get 4. When you square negative 2, you also get 4. So when you take a square root, please put that behind. Put that always in your head, that when you take square root in these equations, you are going to get 2 values. When you only write one value, many students write one value, the positive value, and they forget the negative value. You reduce your answers. You kill some angles. Please don't kill angles. I'm on my knees. Just that my camera is off, but I'm on my knees. Okay, so I'm going to now at this point I am ready to take the sine inverse on both sides. I can say I am taking the sine inverse of the sine theta, the same as me taking the sine inverse of 1 out of root 2. I am dealing with the it looks like I'm dealing with a positive one. However, also when I'm dealing with the negative one, I will ignore the negative. Okay. I have now theta being the sine inverse of 1 over root 2. When you press sine inverse, open brackets, 1 over root 2, close brackets, you are going to get 45. That's what I've done. I have 45. For what do you have? Yes, you have 45. Okay. So theta is 45. But remember, we said those are not our answers. Those are just angles that we must show in the quadrat. So when theta is 45, I am going to come and draw the quadrat here. And I know in the first quadrant, all of them are positive. Sine is positive, tan is positive, cosine is positive. Okay. I took sine inverse of a positive. This was positive, this first one. So I'm going to represent my angles where a sine is positive, my 45. So this angle here is 45. Even this quadrat also, the sign is positive. So even here, the 45 falls there. Now, when I look at this other one, this second one, sine theta is negative 1 over root 2. They're telling me that even I should also represent even in the quadrats where sine is negative. These first two are representing where sine is positive, all and student. That's our first one. Sine theta is 1 over root 2. Now, I also have to represent where sine theta is negative 1 over root 2. Negative, it's negative. It's negative. I'm not going to follow to repeat this procedure of taking sine inverse, because if I followed it, I would get the same value here. Remember, when I'm doing that, when we were having a negative, we used to ignore it. So I'm just going to use the same 45. But I'm going to now also represent it in the quadrats where sine is negative. So you can notice that every example has some peculiar thing. It's not repetition. They are all intentional. Okay. Then I now have to measure the angles from the positive x-axis anti-clockwise. This one is automatically 45. I want to know what angle this is. I also want to know what angle this is. And finally, what angle this is. Okay, so all those together, that is my answer. Make sure they are in the range we were given of 0 to 360. So theta is the first one, 45 degrees. The second one, this was 90. Okay, I want to know now which portion have I added. If from this axis to here is 45, it means the remaining part is also 45 because the whole quadrant is 90. So I actually have 90 plus 45, that is 135. And then this other one is 180. This line here, this line is 180. So I'm adding 45. I get 225. 225. And then the last one, I do 360 minus 45. I get 315 degrees. Yes. So those are my values of theta. Those are my answers. Equation solved successfully. So I want us to do one last example. Maybe not very last, but either last or second last. Which is mature. Mature. Okay. Let's use this same page. This has been the third example. Yes. Okay, I'm going to have to write the fourth example. And the fourth example is D. D is telling us that we are in the same, we are still in the same range of theta values, but D is 4 cos 2 theta is equal to 1. Now I want to take your mind back to the range of values that we were given. We were told that theta lies between 0 degrees to 360 degrees. This we were told at the beginning of the examples. Theta, and all the examples we've been doing have theta. Now this one does not have theta, it has twice 2 theta. So the question and the range are not obviously direct. They're not direct. It means I have to do something. I will either, and most likely, change my range a bit. I'm going to change my range, and I'm going to double everything in this range. I'm going to multiply 0 times 2, theta times 2, 360 times 2, so that I get the range of 2 theta. Because the range that I have is for only 1 theta, 1, but these are 2. So when I multiply 0 times 2, that is 0 times 2 is wastage. Just gets 0. Then theta times 2, I get 2 theta. And then when I multiply 360 times 2, I will have 720 degrees. Okay? Now it is getting hotter. It is getting hotter. If You have some drink, some cold drink, don't blink. You understand this example? So you're going to pass, as others will be fidgeting. So I'm going to make cos 2 theta. I'm going to leave a cos 2 theta on one side. That means I'll divide by 4. And when I divide by 4, I will get cos 2 theta I'll get cos 2 theta as 1 out of 4. When I have that, I can now take the cos inverse on both sides. When you have cos, take cos inverse. When you have sine, take sine inverse. And when you have tan, take the tan inverse. How do you do the tan inverse or the sine inverse? You shift, you press shift, and then you press that function. Yeah. Now, finding cos inverse, they will cancel out. Finding cos inverse, they will cancel out. And I'll remain with 2 theta only. These two have cancelled. I have 2 theta, which is equal to the cos inverse of a quarter. Cos inverse of a quarter, I press that on the calculator to get its value. My calculator, cos inverse of a quarter. Okay, I'm having 75.52. 75.52. I'm going to always write maximum of 2 decimal places when I'm writing angles. But when you are dealing with other form of mathematics, you can write up to 4. So that is my 2 theta. 2 theta is 75.52. Okay, but that's not the answer. I have to represent that in the quadrats. Now remember, 1 quadrat is up to 360, but 2 quadrats, I mean our new range is 720. 720 will mean we are going to make a full rotation and we restart the rotation, as you're going to see. Okay, going to see. We're going to see. I took cos inverse of a quarter, which is positive, so I'm going to put the angle that I have gotten in places where cos is positive. And the 2 quadrats which qualify is the first quadrat, where all of them are positive. I'm going to put there that angle 75.52, and also the last quadrant where cos is positive, and that is B 75.52. Okay. Then I get my values. I read off the values from the positive axis. The first value is 75.52. The second value is this one. But my range is still big. So my values of 2 theta are 75.52. The other one is you take a 360 minus 75. I hope you know why we are taking that. And we are having 284.48 degrees. 284.48 degrees. Now our range, look at our range. It's big. Our range of 2 theta. I am in 200. The range is saying go up to 720. So what I'm going to do, I am going to do more rotations. I'm going to start from this point. I rotate until I come back to this very point, and then I measure up to this angle of 75. I'm going to make one complete cycle, and then I add on 75. That's what I'm going to do. After that, I'm again going to start from here, do a complete cycle, come back at this point, and then measure the other angle, this one, measure this one. If I may try to show that, it's going to be dirty, but let me do that. I'm going to measure. I measure that angle. I again start. But how to easily deal with that? Because now it's even becoming that here. Just get the two angles that you have, and you keep adding 360. So what I've done, I've just added 360 here. The 360 is accounting for that complete cycle. Then I'm also going to add 360 to this one. And I'm having 644.48 degrees. Now my range is up to 720. I have added here 360 to get this one. I've added here 360 to get this one. To get this second one. And the last one, sorry. So what you do, you come on this last one, these last two. We try to make another cycle to see if I make another cycle, does it still fit? I try to add here 360. But when you add there 360 on 435.52 plus 360, you get 790, which is beyond the range. So we stop there. We just stop there. My values of 2 theta, these are the only values which fit in the range. However, my question wants the value of theta, not 2 theta. So what I do, I divide everything there by 2 to eliminate this SOHCAHTOA. So I get my 75.52 divides by 2. You get 37.76 degrees. You have 284.48 divided by 2, which gives you 142.24. You have 435.52 divided by 2. You get 217. Please also try out on your calculator to ensure we're not making an error. And then 644.48 8 divided by the 2, we get 322.24 degrees. Yeah, so those are my final answers. This is the point, 217.30. Now your final answer should all be in the range of 0 to 360, since it is in the range of theta. After dividing, your biggest value should be less than 360. If there's any value which is bigger than 360, you ignore it. You don't write it as part of your answer. And that is it. That is how we solve these trigonometry equations. They are good. They are good. Our time is gone. Today I have not received any question, any word, because people have over understood. But nevertheless, I would love to leave some questions behind for you to try out to check your math muscles. So I have an activity here that I'm giving you in just 1 minute. And this activity is the first question. I'm giving one general instruction: solve for theta 0 less than or equal to theta. My good. Which language am I writing? 0 less than or equal to theta which is less than or equal to 360 degrees. And the first question you're going to do is the sine squared theta is equal to 1. We solve for theta in that equation. This is 1, not 7. The second question that you're going to do is the sine squared to theta is equal to 1. These are two different questions. Okay. And finally, part C, I love giving 3 questions. Is the sec of 2 theta being equal to 3. Yes. If you do those questions and you prove them by putting back the angles here, and you do them rightly, they come out rightly, this lesson has yielded enough for you. And I would love to close at that, if I am allowed. Yes. So I would welcome any communication, any question. Yeah, it has been a good time. Thank you for the attention. Until next time.
Okay, thank you so much, Mr. Wafula Trevor. Thank you for that very good lesson. It's been, I don't know mathematics, but I think I've been in class all along. So thank you very much. This and all the other live classes are recorded and they're uploaded on the Magezi Harvest platform that you can access at harvest.magezi.space. So you can always visit the platform to access all the classes for further insight and any reference or clarity that too. Thank you so much, Teacher Trevor. We meet again next week.